This is the course grade example that we discussed a couple weeks ago. Recall that the course grade example computes the final grade as a weighted sum of the scores in exam, lab, and homework. In this program, although we are using an object-oriented language in implementing the program, we were not really using an object-oriented approach. The program consists of just one long sequence of code. The program also did not distinguish the grades from different students. Let's redesign the program using an object-oriented approach by allowing the program to create different instances of grades for different students. For example, we can think about creating a grade report card for each student in a class. This could be a sample of the grade report that we want to generate at the end of a course. In fact, you are already equipped with all the tools to generate something like this, although you may not be able to get perfect scores like what I did here. Let's change the name of the class to CS 101 grade instead of course grade to indicate that the class generates instances of grades for students in the course CS 101. These are the variable declarations that we had before. When we discussed the weighting factors including exam weight, lab weight, and homework weight, in addition to making it final, that is constant, we also mentioned that this could be the same for all students in the same class. That is, instead of belonging to a particular instance of a class, they actually apply to the whole class. In Java, this is the concept of class variable, or they are also called static variables. The keyword static is used to designate class variables. Static variables will be created without the need to create any instance. So here, we are declaring exam weight, lab weight, and homework weight as static variable by putting the keyword static in front of the declaration. To distinguish different instances of CS 101 grade objects, we are also introducing an instant variable student name of string type. This is declared as an instant variable because the owner of the CS 101 grades for one student could be different from the others. Here is the declaration of a constructor for the class CS 101 grade. The constructor simply assigns the name of a student given as parameter to the instant variable student name. We then declare a method for obtaining all scores for a student. The I/O statements are similar to the program before. The difference here is that we are grouping a set of similar actions into a method called getScores. This is the method for computing the final grades as a weighted sum of exam, lab, and homework scores. Notice that the method takes 3 parameters, all in double, and returns a value also in double. The return value is computed as the expression specified in the return statement. Notice also that we are using the same names, exam score, lab score, and homework score, for the parameter as well as for the instant variables. They don't have to be the same. I'm doing this deliberately to show you how the meaning of identifiers with the same name could be resolved using the scope rules. 2 more methods are defined here. Set final grade. It calls the method compute grade that we defined earlier to set the value for the instant variable final grade. And the method output results simply outputs the results of all the scores and the final grade computed. Let's now take a more careful look at what this would happen when the method compute grade is called in the method set final grade, using the instant variables exam score, lab score, homework score as the arguments. When we introduce variables, we use a diagram of storage bins like this to illustrate memory allocations for variables. Let's use a similar diagram to illustrate what would happen to the variables when a method is called. When an object is created or instantiated, memory space would be allocated to the class variables and instance variables. Here, the first 3 class variables, which are declared as constant, and the next 4 are instance variables. Assuming that exam score, lab score, and homework score have been initialized respectively with values 90, 80, and 70 using the getScore method, while final grades has not yet been given any value. Let's look at the process when the compute grade method is called using the instance variable exam score, lab score, and homework score as arguments. This is the method compute grade that we just described. Notice that compute grade has 3 parameters, and parameter variables is treated as a type of local variables in Java. When the method is called, new memory space corresponding to the parameters will be allocated. Notice that although the instance variables and the parameters are given the same names, they occupy different memory spaces. A copy of the value of the parameters will be placed into the corresponding memory cell for exam score, lab score, and homework score in the compute grade program. After the parameters have been initiated, the first statement inside the body of the method could be executed. The expression inside the parentheses on the right-hand side of the assignment statement will be executed first, and it will need to look up the value for the variable exam weight. Since exam weight cannot be found inside the method compute grade, it will look outside the method and find that the closest definition for exam weight is when it is declared as an instant variable. So 70 is used as the value for exam weight. The next operation is to multiply the exam score with the result of the division in the parentheses. But the program will find that 2 versions of exam score appear in the program. One as parameter variable inside the method compute grade, and the other as an instant variable with the same name. The scope rule, which I'll discuss in more detail later, will look up the meaning of a variable from the closest block where it is declared. In this case, the parameter variable would be used. The result would then be assigned to the memory space corresponding to the parameter exam score, thus changing its value from 90 to 63. Similarly, the second assignment statement would replace the value of the parameter variable lab score from 80 to 16. And the third assignment statement would replace the value of homework score to 7. The last statement in the method would return the value of the sum of all the weighted scores and return a value of 86.